solve using Gauss-Jordan. The first thing you will do is you will present the information as an augmented matrix. The coefficient of the first row is 1, 1, 1. And then you put a line here. Then you put 3. Second row, 2, 3, 7, 0. The third row is 1, 3, minus 2, 17. So once you have it in this form, then you eliminate use the elimination technique and try to make these entries go to 0. It's up to you which one you want to do first. The more you practice, the more you get a better idea what to do. So let's say if I want to make this go to 0, if I want to make that circle in red go to 0, so you'll try to do the easiest things first. And it's quite easy to do that if you look, push it a little bit. To achieve that, you subtract from row 3, row 1. Row 3 minus row 1. So when I say row 3 minus row 1, the change is going to happen to row 3. Okay, so if you have a problem doing this in your mind, then you can write it down. The row 3 is 1, 3, 2. Minus 2, 17. This is row 3. Then you subtract row 1. 1, 1, 1, 3. Row 1. So you subtract them. 1 minus 1 is 0. 3 minus 1 is 2. Minus 2 minus 1 is minus 3. 17 minus 3 is 14. 17 minus 3. Okay, I think it's the other way around. Sorry. Should be. Okay, there's somebody got the mic on. Some of you guys, I don't know what you guys are doing. You know, every time I have to tell you this. So row 3 is 1, 3. Okay. Row 3. I think I got that right. Did I? Row 3 minus row 1. Row 3 minus row 1. Okay, I think I got that right. It's okay. We will do that again. It's row 3. Okay. Okay, that's what I had earlier. Row 3 minus row 1. So 0 to 0 to 0 to minus 3 minus 14. Sorry, 14 plus 14. Is that correct?
Yes, sir.
Okay. So you are flexible to do different operations here. So the next thing, so we already made one of them go to 0. The next one you want to make to go to 0. Maybe you can make this go to 0. So you do one row at a time. It'll be easier. Don't try to do too many rows at the same time. If I get confused, if I can't follow what you're doing, then it's really bad. Okay? So I should be follow. Your aim is not to get the answer. Your aim is to show me how you're proceeding to solve the problem. So to make that go to 0, what I can do is I can go 2R2, 2 times row 2. Sorry, 2 times, row 2, minus 2, row 1. See, row 2 is 2, 3, 3, 7, 0. It's row 2. Then 2, row 1 is 2 times row 1 is 2, 2, 2, 6. Then you subtract. So in that way, you can make this, when these two becomes the same, you can make them go to 0 by subtracting one from the other. When you say row 2 minus 2 row 1, the change is going to happen here. The change is happening here. You don't make the change to row 1. So you guys have to be very careful in doing this. So 2 minus 2 is 0. 3 minus 2 is 1. 7 minus 2 is 5. 0 minus 6 is minus 6. So it's going to be 0, 1, 5, minus 6. Okay, so next one. Now I can try to make this go to 0. So if you want to make that go to 0, then you have to look for ways to make that go to 0. See, I can do this like, I can go like row 3. I can say, okay, row 3 minus 2R1. Okay, if I do that, what will happen is, so it will make the already established 0 become non-zero again. Okay, so you don't want to do that. So you don't want to use row 1 in this operation. You want to use row 2. R3 minus 2R2. Or R3. So if you do that, R3 is 0 to minus 3, 14. Minus 2R2. 2 times R2 is 0 to 10. And then minus 12. So you subtract minus 0 minus 0 is 0. 2 minus 2 is 0. Minus 3 minus 10 is minus 13. Then 14 minus minus 12 becomes 26. So it's going to be minus 13, 26. So you already achieved all the zeros that was needed. So we achieved the zeros that we wanted to achieve earlier, remember? So we achieved all the zeros. So next we go and look at this. Now we are going to try to make this go to 0. Why don't you guys spend a few minutes thinking about it? Give yourself, take a piece of paper, and I'm going to ask you questions now. Each one of you take a piece of paper and writing tool and try to make this go to 0. Try to make this one go to 0.
Five R1 minus R2, sir.
5 times R1 is 5, 5, 5, 5, multiplied by, so it's 15, right? You say
Yes, sir.
15 minus R2. R2 is 0, 1, 5, minus 6. So you're saying like this, 5 minus 1 is 5, 5 minus 0, 5 minus 4, then 5 minus 5 is 0, 15 minus 6 is 21.
21.
Huh?
Yes, sir.
Okay, 21. So that also, okay. So they're going to get 5, 0, 4, 0, 21. So when you do this, you must tell me exactly on which row the change is happening. Don't simply think something in your mind. You must specifically tell me the change is happening here. If you go and simply write somewhere like this, I will not buy it. The change is happening to which row? You must tell me. You have to indicate specifically.
Okay, sir.
Okay, very good. The next, if I want to make this go to 0, so how do I do this. So next time, if I want to make this go to 0, then what can I do? So the only thing that can make to 0, if I do an operation, if I do, so I cannot use this row. I cannot use this to make this go to 0 because this is already 0. So I only have to use this to make this go to 0. Okay. Then in that case, what I have to do, I have to make this to make this one go to 0. I have to R1, R2, okay, plus 5 over 13, or 13 over 5 over 13. Sorry,
5 over 13, sir.
huh? Say
5
that
over
again.
13. 5 over 13, sir.
5 over 13, and then
R3, sir.
R3. Okay. So if you do that, okay, let's erase all this. R2 is 0, 1, 5, minus 6. 5 over 13, R3 is 0, 0. Then this is minus 5, right? And then this will be 5 over 13 times by 26 is how much? 5 over 13 times 26 is 2. Sorry, 10. Am I right? 10 is it?
Yes, sir.
Yes, sir.
So if you add them up, 0, 1, 0, and 4. 0, 1, 0, 4. So that would also work. And then, is this okay? So far, any problems? So next, we try to make this go to 0. So how do we make this go to 0? Okay, give you guys 3 minutes, think about it. So how do we make this go to 0? Any volunteers? Tanzan Hui? Tanzan Hui?
Yes, sir.
Do you know how to make that go to 0? Okay, how about Fong?
As we previously could do this first.
Okay.
At the
How
first,
about Zifeng?
So R1 minus 4R2.
R1
No, yes, R1 minus
minus
4R2.
4R2. Okay, I think sounds like a good idea. So R1 is 540 4021. R1. It's R1, right? And then minus by 4R2. R2, 4R2 times row 2 by 4. 0, 4, 0, 16. So this is 4R2. So if we subtract them, 5 minus 0 is 5. 4 minus 4 is 0. 0 minus 0 is 0. 21 minus 16 is 5. 5005. Okay, good idea. The reason why he choose row 2 and not row 1. Why Zifeng chose this to be row 2, but why not row 1? Because in row 1, sorry, why not he choose this to be row 3? Why he didn't choose row 3? Because you cannot use row 3 to make this go to 0. You cannot use row 3 to make this go to 0 because row 3, the entry here is already 0. So these are the kind of things you have to think before doing it. The rest is simple addition and subtraction. So the last thing you have to do, you're still not done. You are still not in the Gauss-Jordan format yet. To put this into the Gauss-Jordan format, what should we do to put this in Gauss-Jordan format? What should we do? Jessica?
Let's make the rest of it 1.
So how do you do that, Jessica? The row 1, what do you do?
Just divide by 5. Then
Okay,
second
good.
one divide.
Very good. So we are only interested in making these things go to 0. How about row 3?
Divide by negative 13.
Row 2, you don't do anything. Row 3, divide by minus 13. And this becomes 2. Okay, guys, good job, all of you who participated in this. So you know that this is X, and this is Y, and this is Z. So then now you can conclude. From here, you can determine what X, Y, and Z. G, can you tell me what is X equals to what?
1, sir.
Y,
4,
and then Z,
2.
2.
Yes, sir.
So I made a mistake here. Supposed to be minus 2, isn't it? When I divide by minus 13. Do you guys agree? When I divided this by minus 13, it should have been minus 2 here. So now tell me Z, what is Z?
Minus 2.
Z. So it's quite easy. As you can see, it's very easy to make mistakes. Gauss-Jordan. What's the problem here? X plus y plus z, x plus y plus z is 5. 2x plus 3z, sorry, plus 3y plus 5z is 8. Then 4x, 0y plus 5z is 2. So now we write the coefficient of the first row, 1, 1, 1, and equals to 5. Coefficient of second row, 2, 3, 5, equals to 8. The coefficients of the third row, 4, 0y, and 5, coefficient of z equals to 2. So these are the augmented matrix. Then from there you start your row operations. Why don't you guys try to do this problem by yourself? I give you around, say, 10 minutes. Okay, let's do it together. We can start by, if you look, your goal, your focus is to try to get these entries go to 0. But in this case, one of them is already 0, but that doesn't mean it's going to help. And then you also need to try to get these entries go to 0. So let's start. We can start just randomly. I'm starting from here. So let's start by doing this because I saw an opportunity to make this and this go to 0. But I can make this to go to 0 instantly, but I'm going to do one at a time. So try to spend some time, do one at a time. In that way, you will never go wrong. Even if you go wrong, you will get good partial credit. If you don't show enough steps, if you make any mistakes, then it's difficult to follow you, right? So the change is going to be R2, let's say I'm going to do R2, the row 2 going to be changed by subtracting 2 row 1. So row 2 is 2, 3, 5, 8 minus 2 times row 1. Row 1 multiplied by 2 is 2, 2, 2, 10. Subtract 2 minus 2, 0, 3 minus 2. Okay, this entry is for row 2. Okay, this is going to be entered in row 2. 3 minus 2 is 1, 5 minus 2 is 3, 8 minus 10 is minus 2. So it's going to be 0, 1, 3, minus 2. So next, I'm going to make this go to 0. When I try to make this go to 0, maybe this will become non-zero, but it doesn't matter. You have to proceed this way. There's no other way. Eventually, this will go to Once you try to make this go to 0, this will become non-zero, but it's okay. Eventually, you'll make it go to 0 by subsequent row operations. So go ahead and delete this because the operation is on row 3. So what we can do, so we already have ones here. So if I multiply that by 4 and subtract from row 3, that would work. So it's going to be like 4 row 1, sorry, row 3 minus 4 row 1. Row 3 minus 4 row 1. Row 3 is 4, 0, 5, 2. 4 times row 1 is 4, 4, 4, 20. Subtract them, 0, minus 4, 1, minus 18. So go ahead and enter this here, 0, minus 4, 1, minus 18. So this entry, this change is for this row. Next, are you going to make this go to 0, which can be easily done by multiplying row 2 by 4 and adding it to row 3. R3, if it, row 3, you add to row 3, row 2 multiply by 4. So row 3 is 0, minus 4, 1, minus 18. 4 times row 2 is 0, 4, 12, minus 6. If you just add them up, you get 0, 0, 13, 26, minus 26. It's going to be 0, 0, 13, minus 26. Personally, I don't like to deal with very large numbers like this one. They're big numbers. So I'm going to divide these numbers by 13. So row 3 divide by 13. So next, So once I have them in a small number, so it's easier to make things go to 0. So next, you can try to make this go to 0. I can easily make this go to 0 by doing this R1 minus R3. That's one of the reason for subtracting through by the row through by 13. So R1 1 1 1 5 minus R3 0 0 0 1 minus 2. Subtract, you get 1 minus 0 1 1 0 5 minus minus 2 7 1107. Next, you want to make this go to 0. That can be easily made to 0 if you multiply it with row 2 and then you subtract row 2 3 times row 3. R2 0 1 and 3 minus 2. Row 3 3 times row 3 is 0 0 3 minus 6. If you subtract 0 1 0 minus 2 minus minus 6 is minus 2 plus 6 is 4. 0 1 0 4. There's still one more culprit. This one. You guys are okay so far? Are you all still connected?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
Okay, the next
sir.
one is, so the next one, you can easily make this go to 0 by subtracting row 1 by row 2. Row 1 minus row 2. Okay. You cannot do row 3 because row 3 is already 0. One, 1, 0, 7, this is row 1. Subtract row 2. 0, 1, 0, 4. 1, 0, 0, 3. So 1, 0, 0, 3. 1, 0, 0, 3. So we are done here. We achieved a diagonal 1. We have already achieved diagonal 1. It has to be 1 and it has to be positive. Then it is in Gauss-Jordan format. Gauss-Jordan. So now we can conclude x is 3, y is 4, and z is minus 2. Is equals to 4. Okay, you guys do it by yourself. You'll end up getting something like this. 1 0 0 0 1 0 minus 7 over 4 0. It doesn't mean that you're going to be getting exactly the same thing. You can get slightly differently. Zero. So you'll end up getting something like this. So in this case, you may get something slightly differently from what you see. Maybe there's some sign, might a little bit different, or maybe it will be fractional over here. But the main idea, see right here is 0, you know. Can you see? It's that way, because what this means, do you know what this means? When you have all zeros here, zero means don't worry about it. So you just be concerned with this too. Okay, so from here, you'll get x minus 7 over 4y is equal to 0. And then from here, you will get so from row 1, x is 7 over 4y. And then y is 1/2 minus 1 over 4z. So what about z? If you look here, we look at this last row. There's no specific value for z. It can be chosen arbitrarily. There's no specific value for z. There is no specific value for z. It can be chosen arbitrarily. Last time when you do, remember last time when we were working on, not this semester, maybe in mathematics 1A when we are doing eigenvalues. So you might have come across this, but it's okay. So There's no specific value for z. It can be chosen arbitrarily. This means there are infinitely many. So this means that there are infinitely many solutions for the system. We can present all the solution by using, we can present, therefore, we can present, we can represent all the solutions by using a parameter t as follows. Now you can just say, okay, z, we don't know what is z, so we just let z to be t. Because z can be any value, right? It can be 0, I don't know if it can be 0, but let's z to be t. If z is t, then x is, we substitute if z is t, then y, x is 7 over z. Okay, there's a typo error here, and nobody is helping me out here. Z here, right? Supposed to be z. Are you guys sleeping there? Hello? Are you guys paying attention?
Yes, sir.
Yes, sir.
Then why don't you see I make mistakes and nobody is paying attention to this? Okay, z is t. If z is t, then y is going to be, x is going to be 7 over 4t. It's in red color, it's okay. Change it back to, we change all back to blue, sorry, black. So that means what is y is going to be? Y is equals to what? G. G.
Yes, sir.
Y is equals to what?
1 over 2 minus 1 over 4, C.
1 over 2 minus 1 over 4 t. So
T. Okay, guys, I don't know what you guys are doing. It's very important. See, now I already defined Z is T. So wherever there's a Z, it should be T, isn't it? So wherever there was, a Z, it should be T. Right, G? G.
Yes, sir.
Any value of the parameter So what is this parameter we are talking about? What is the parameter? Parameter T gives us a solution of the system system. For example, if you choose, t is equals to 4, if you choose t is equals to 4, that gives the solution xyz. So that gives a solution x, y, z equals to, so now you have chosen t is 4. So now you take the t, you have chosen t is 4. Can you guys see this clearly? Now you have chosen t is 4. T can be any value, it's a parameter. You can also choose 0. Let's say we choose t is 4, then you can put the t here. That means z becomes t, right? And therefore, z becomes 4. Now you replace all the t's here with 4. Also here. So when you replace them with 4, your x is going to be 7. Y is going to be 1 over 2 minus 1 over 4 multiplied by 4. Cancel, 1. 1 half minus 1 is minus half, right? And then z is going to be just 4. So let's say, for example, if t is chosen as minus 2, t is chosen as minus 2. If t is chosen as minus 2, what will be the value of x? Is equals to what? Valarmadi?
Yes, sir.
Valerie, if you see when t is equal to 2, then x is 7 over 4t, right?
Yeah.
Isn't it?
Yes,
Then it's
sir.
going to be 7 over 4 minus 2 is how much?
3.5, sir.
Okay, 3.5 minus 7 over 2. So it's minus 3.5. So minus 3.5, Valerie. Agree?
Yes, sir.
Please pay attention, all of you. Please put all your phones away. Okay? And then just focus on this. So x is minus 7 over 2. Y is equals to what? Y is equals to what? Y is equals to what? How about Yenda? Y is equal to?
Y is equal to 1.
Okay, 1 half minus 1 over 4 minus 2 minus plus 2 over 4 is equals to 1 over 2 plus 1 over 2 is 1. Very good. When t is minus 2, now I'm asking you what is z equals to? What is z going to be? Let me see who can answer this question. Let me see. Paitran? Z equals to what?
Z equals to -2, sir.
Okay, good. Zero, 4, 1, 2, 2, 6, minus 2, 3, 4, 8, minus 5, 4. I'm doing this problem here. You can try to make this go to 0. You can also change rows, okay? Because if you see right here, 0 is not desirable here, okay? But the 0 is desirable here. So we can move the entire row. We can switch row. Simply by switching row. Okay. That is okay to do. So 1 to 0 is achieved. You just exchange rows. Exchange row. Exchange row 1 and 2. Next, you can try to make this go to 0. So we can achieve this if I subtract row 3 by 2 times row 1. So that's going to give me row 3 is 4, 8 minus 5, 4. 2 times row 1 is 4, 12 minus 4, 6. 4 minus 4 is 0. 8 minus 12 is minus 4. Minus 5 minus 4 is minus 1. 4 minus 6 is minus 2. 0 minus 4 minus 1 minus 2. Sorry, I made the wrong entry. Okay, okay, that's right. Okay. 0, minus 4, minus 1, 0, 4, 1. Okay. Any questions so far? Any question? Are you all still connected?
Yes, sir.
Yes, sir.
So the next thing is easily you can combine these two. Okay, you can see this, you can easily combine them. And then you also can easily see if you add this to row 3, it will go to 0. Or it can be the other way around also. One of the rows is going to go to 0. Okay, if you add this, if you go row 3 plus row 1, row 2, so that's going to make all the row 3 go to 0, right? This will make row 3 goes to 0 for row 3. So if you go R2 plus R3, that will make only the coefficient part. That will make row 2 go to 0, right? So let's try to do it differently this time. So I'm going to add, as we said earlier, there's no problem. We can always change rows or do whatever. So now I'm going to add row 2 plus row 3. 0, 4, 1, 2 plus 0, minus 4, minus 1, minus 2. So in this case, everything, the row 2 will go to 0. Okay, differently, I'm doing it slightly differently because the other time we had all row 3 go to 0. Now I'm just making all the row 2 going to 0. But it doesn't matter because you can always switch rows. But still it means the same thing. So what else can we do? We try our best to do. You can either do that, or since we are trying to achieve Gauss-Jordan, it would be desirable to have the 0 here, right? So let's go back here and to try to do this. So now you go like this, row 3 plus row 2, 0, 4, 1, 2, 0, minus 4, minus 1, minus 2, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0. So we already achieved this part, making this going to 0. But we have another 0 here, which is not usually Gauss-Jordan, but the process of trying to make this all go to 0. So at the end, whatever the outcome, we accept it. So now let's try to make this go to 0. Let's try to make this go to 0. That can be easily done by adding to row 1 plus to row 2. So row 1 is 2, 6, minus 2, 3. 2 times row 2, 0, 8, 2, 4. Add them up. Get 2, 14, 0, 7. Two 14, 0, 0, 7. Okay, now at this point, what else can I do to make this? If you look carefully, this is one of the 2 other things to the left that I can try to make it go to 0. All right. Unfortunately, you are not able to, you won't be able to make this go to 0. Can you? You cannot make this go to 0, right? I mean, it's the way it is right now, because if you add any other rows or subtract any other rows to this row, it's not going to make it go to 0. So let's try to work on this. Let's try to make this go to 0. We can make this go to 0 if you row 1 plus or minus row 1 minus 4 over 14 or 4 over, sorry, 14 over 4. 14 over 4 R2. Okay, R1 is 2, 14, 0, 7. Minus 14 over 4. R2 is 0 here. It's minus 14 here. It's minus 14 over 4. And then the last one, minus 14 over 4 multiplied by 2 is cancel 2. It's minus 7. It's minus 7. I don't know if I'm doing this correctly. Please let me know if there's any algebra problem. So subtract, 2 minus 0 is 2. 14 minus 14 is 0. 0 minus 14 over 4 is 14 over 4, which is 7 over 2. And this is 0. Two, 0, 7 over 2, 0. So when I try to make that one go to 0, this one becomes non-zero. So there's a problem here, Look, it's difficult for you to make all of them go to 0. So what I can do, I can just stop here. I think that's the best I can do. So once you know that you cannot make all these things go to 0, if you're sure that you cannot make this go to 0, because when you try to make one go to 0, the other one becomes non-zero. So if you come to a point that if you cannot make all this go to 0, then you stop. And then you stop. Now you try to make all this and try to make all this become 1. Okay. But this one cannot become 1 because it's already 0. So since this is easy to do, I'm going to do this simultaneously, the same in the single step. I'm going to divide row 1 by 2. Here I'm going to divide row 2 by 4. So in that way, you'll get so row 1 divided by 2. Row 1 divided by 2 becomes 1 here, 0, 7 over 4, and 0. Row 2 divided by 4 row 2 divided by 4 is 0 here, 1, and 1 over 4. Divided by 4, it then becomes 1/2. Okay, that's a problem here. I forgot to repair 0 minus, this is minus, isn't it? It's supposed to be a minus here, is it? It's supposed to be a minus sign here. Am I right? So it's supposed to be a minus sign here. You forgot. It's supposed to be a minus sign here. So you can see, you can make a simple algebra mistakes, sign errors. So I recommend you just do step by steps, avoid doing things hastily. So you managed to achieve 1 year, but except the 0, you cannot do much about it. So when a situation like this, still you have the same solution.
So
Yes,
there's no minus sign over there because 0 minus minus is 14 over 4. Sir.
0 minus,
Minus 14 over 4, right? So minus minus will be positive. Am I right?
okay, row 1 is 2. See, this is row 1. This is row 1, isn't it? Row 1 is 2, 14, 0, 7, correct?
Yes, sir.
Okay, row 1. So 2, 14, 0, 7, right? Right here. This is row 1.
Yeah.
Okay, now minus 14 over 4, row 2. So this is, there's already a minus sign. Hold on a second. There shouldn't be a minus. Of course, I know there shouldn't be minus sign here because the minus sign is already outside here. Minus sign is already outside here. So that's the mistake I made. Put the signs 2 times. It confuse you.
Okay, sir.
Thank you for the observation. Sorry about this. So once you put the, maybe you put a parenthesis, much better, you know. So minus 7 over 2. Because earlier on I put a sign here and then I put a sign outside here, and of course it becomes positive. What do you think? JJ, is it all right?
Yes, sir. Correct.
Okay. Okay, thank you. So you guys, please check for me. You know, I can make mistakes. We don't want to upload something with mistakes to the whole world to see. Each one of you, please